The shape of thrust. In 2350, propulsion was no longer about speed. That misconception lingered mostly among civilians and politicians, people who still thought in terms of destinations instead of vectors. Engineers knew better. What mattered now was control not just of momentum, but of stress, waste, and failure modes that unfolded over years rather than seconds. The ship Helix 9 was never meant to be elegant. It was a test platform, a long, asymmetrical spine of tanks, field coils, and radiator vanes, built to answer a question that had survived every generation of engine design. Could thrust be reshaped without reshaping the ship? Dr. Ilya Korovin watched the engine diagnostics scroll past with a familiar mix of anticipation and dread. Fusion-adjacent drives were mature, reliable, and deeply conservative. Every design iteration nudged efficiency upward by fractions of a percent. Radical ideas were frowned upon not because they were unsafe, but because they complicated everything downstream. This one complicated everything. The variable geometry exhaust chamber was Ilya's obsession. Traditional drives expelled plasma through fixed magnetic nozzles, shaping thrust along a single axis. Helix 9's engine used dynamically reconfigurable field lattices, allowing the exhaust plume to shift shape in real time. Not direction. Shape. The idea was simple in theory. If thrust stress could be distributed asymmetrically, structural loads on long-duration vessels could be managed without constant mechanical adjustment. Less wear. Fewer failure points. Longer operational lifespans. In practice, plasma did not like being told what to do. Field coherence holding, said Anya, the system's lead. Barely. Begin modulation, Ilya said. The exhaust plume bloomed, no longer a tight cone but a flattened fan, shimmering against the void. Sensors lit up as stress redistributed along the ship's spine. For 30 seconds, it worked. Then the vibrations started. Not violent. Worse. Subtle oscillations that crept through the structure like a resonance seeking a voice. The field lattices fought to maintain coherence as micro-instabilities cascaded. Abort, Anya snapped. The engine cut. Silence returned. Damage reports followed. Nothing catastrophic. But the lesson was clear. Shaping thrust reshaped failure. Over the next weeks, they iterated. Narrow fans. Split plumes. Hollow exhaust shells. Each configuration solved one problem and birthed two more. Heat concentrated where it shouldn't. Magnetic shear ate at containment margins. Control algorithms grew increasingly baroque. The breakthrough came by accident. During a partial test, a sensor fault forced the system into a degraded mode. The exhaust plume fragmented into layered strata, each slightly out of phase. It should have collapsed. Instead, the vibrations vanished. The thrust wasn't smooth. It was textured. By allowing controlled turbulence within the exhaust, stress waves cancelled rather than amplified. Efficiency dropped slightly. Longevity increased dramatically. The shape of thrust was not a single answer, but a spectrum. Helix 9 would never be fast. But ships that followed might fly for decades without refit. The cost was complexity. Control systems that required constant vigilance. New failure modes that could not be ignored. Progress, as always, arrived with teeth.